I want to start to introduce our first keynote speaker, and I am really honored to have her here. It's Trisha Gee, and I wanted to inspire a little bit our um, listeners, our attendees, and ask Trisha a question. Trisha, when and how did you start your journey of a public speaker?
Right. Hello. Can you hear me?
Yes.
Excellent. Is my video on?
Yes, your video is on.
Excellent. Awesome. Yes. Hello. How did I start my journey as a public speaker? A bunch of people told me I should do it, and so I sort of did it. That sounds easy, right? Uh, I was going to user groups. I was going to the London Java community, and I saw people presenting there, and I saw and I met a lot of people there who became my friends, and I had a lot of opinions, and I spoke a lot when I was in the pub, and then the leaders of the London Java community sort of said to me, perhaps you should start presenting, and I was like, oh, that sounds like a good idea. Then people will have to listen to what I have to say. And so I did a few lightning talks, and then I did, my boss was presenting at Java 1, which I managed to get a ticket to, and he invited me to co-present with him, and I liked it. And then I just kind of like went from there. I mean, it sounds easy, but it wasn't easy. There was a lot of like forcing myself to do things which were very uncomfortable, but it's totally worth it. You know, you get to meet a lot of people, you get to travel, you get to change your job to something which is more like shaped around this kind of thing. And yeah, and it was well worth it.
Could you share one piece of advice with our audience on how to, you said that you had to force yourself in doing things, and so what would be your advice for someone who's just starting?
I think the thing that a lot of people think is that they don't have anything to talk about that people want to hear, and it's a concern that obviously we feel a bit concerned about that because we want to have value. What's interesting to me is that in my experience, lots of people want a beginner's guide to, or my experiences with, or, it doesn't have to be deep dive into something that nobody else knows. It can be just like, well, I found this difficult and this is how I got around it. Or, maybe, so I used to work for MongoDB, and I always thought people wanted like in-depth like sharding advice or something, but really what a lot of developers want to know is, how can MongoDB help me? How do I get started? And so I think when it comes to topic, you don't have to do something really esoteric or niche or difficult or deep. You can literally take something that you are good at, something that you think is easy. I can assure you lots of other people don't think it's easy at all. So if you take something that you think is easy, that you know a lot about, or that you maybe struggled with and now understand, and then pitch that to people who don't know anything about it, there'll be a big audience for that.
Thank you so much. This is truly inspiring. And so currently, Trisha is a developer advocate with JetBrains, and she's promoting a lot of things on her blog and annotated monthly newsletter. So everyone should subscribe to that. A lot of good stuff there. Especially, I love March annotated monthly, because that contains a lot of diverse blog authors and everything. So thank you for doing that. I really appreciate that, and I believe a lot of people appreciate that.
Thanks. I think it's really important to get diverse voices, and you have to work at that, but it's well worth it.
Yeah. All right. So today, Trisha is going to share with us the life beyond the Java 8. So without further ado, please start.
Yes, today I'm going to talk to you about life beyond Java 8. I am Trisha Gee. I am the Java Developer Advocacy Team Lead now for JetBrains. We have 4 members of the team, and I have the privilege of leading an amazing team of developer advocates for JetBrains. What I want to talk to you today is and I'll try and talk, I will end up talking faster than I probably should because I have a lot to talk about. It's all about stuff that's happened in Java since the version of Java 8. first, a very quick plug. I very recently edited a book, 97 Things Every Java Programmer Should Know. O'Reilly have given me the opportunity to give away 5 copies of this book at the end of this talk. So if you hang on till the end of the talk, there's a link that you can click on, not this link, this is a different link, a link that you can click on to register to win 1 of 5 copies of the book. So why Java 8? The reason I am talking about beyond Java 8 is because the majority of developers are still on Java 8. This is a copy of 2 different surveys which show that the majority of developers are using Java 8, a chunk of them on 11. This is the results of the JetBrains developer ecosystem report from the start of this year. So 75% of developers are still on Java 8. These numbers don't necessarily add up to 100 because different teams, sometimes some teams are running more than one application, and so they are using more than one version of Java. But you can still get an idea that that the majority of developers are on Java 8. This distribution might look a little bit weird if you don't understand the impact of the new release cadence and the new support model. Why would there be a bunch of people on 8, a bunch of people on 11, and then kind of people scattered around the other versions? And hopefully that will become clear as we go through the presentation. So let's do a quick overview of the changes to the releases, updates, licensing, and support, because this explains the different options that you have when you're upgrading, because things have changed since Java 11. Ever since Java 9, Java has been released every 6 months, which is a big change for us in the Java world. We used to get a release every sort of 3 years, 2 years, like between 6 and 7. I think it was like 5 years or 6 years. And now we're releasing every 6 months. And this is like clockwork. Every September and every March, we get a new version of Java with more or with fewer or more features, depending on what made it into this release. Now we have effectively 2 different types of releases, because Oracle specifically doesn't want to be supporting all of those releases of Java for like ever. So they have nominated 1 release every 3 years will be a long-term support release. This was Java 8. Java 8 was a long-term support release. Java 11 is a long-term support release and will be supported for at least 3 years. And I guess probably Java 17 will be a long-term support release. So this explains why developers are either on Java 8 because it's familiar and comfortable and a long-term support release, or on Java 11 because that's the current long-term support release. This is the story from the Oracle point of view. And for them, you have to pay for support and updates for the long-term support releases. However, Oracle is not the only vendor in town. I don't have a slide for that. Oracle is not the only vendor in town. There are other places to get your JDK from, but so they're going to have differing approaches to updates, support, and so on. But Oracle kind of sets the pace for the Java community because they are the custodians of Java. So effectively, you have two options when you're upgrading. You can upgrade to Java 11, which is the current long-term support release. It should be supported for approximately 3 years. This is generally accepted across the vendors. It's not just Oracle. And you'll get like 3 or more years support for Java 11. Or you can choose the most current release, which right now in where are we? December 2020. The current release is Java 15. And generally, if you're not using a long-term support release, it makes sense to keep upgrading every 6 months, because once Java 16 comes out in March 2021, Java 15 won't get updates. So as I said, there are multiple vendors, and the story does vary a little bit from vendor to vendor. So it is worth investigating who you're going to use. Adopt Openjdk is a good one to look at because it's community-led, it's free, you get support and updates. And so that's a good place to start if you're not really sure who you should be looking to provide your JDK. Right, I do have to do a quick kind of plug for IntelliJ IDEA in this area because I'm the developer advocate for IntelliJ IDEA. And IntelliJ IDEA has recently introduced a new feature which allows you to, it will identify all the JDKs on your hard drive. It will allow you to also download JDKs. And from there, you can also select which vendor you want to download, which version, and so forth. So that makes it a little bit easier figuring out what your options are and which one you're going to go with. So all of that, having said all of that, why bother? This sounds a little bit confusing. There's all these different versions and there's different support options. And Java 8 was kind of like, I kind of liked Java 8. It had streams, it had Lambdas, and it did everything I wanted it to do. So it does kind of beg the question, why should we upgrade? So this is where we get to the sort of meat of the talk, where we're going to look at the features that have come into Java since Java 8. First, we're going to look at the features which are available in Java 11. So these are features that came in either in Java 9, Java 10, or Java 11. So if you opt to go to the long-term support release, these are the features that you can expect to see. Firstly, JShell. I think this is an interesting feature. Let me quit out of this and go to my terminal. JShell is an interesting feature because it is the REPL for Java. Let me show you. So JShell. You can see I'm using JShell in version 11. It's a command line tool, so actually you don't need, it's nothing to do with the version of Java that you're running your application in. So this allows you to play with different versions of Java right now without impacting your application, your development, whatever. I'm demoing version 11 JShell, but you could use 15, you can use 14, 13, whatever you want to use. And it allows you to kind of play with these new features without having to change anything to do with your application. For example, you can be playing with var. So var, my name is Trisha. And so you can play with that, see what that looks like. You may or may not notice something very interesting about JShell for Java developers. There is no semicolon on the end there. So JShell allows us to do away with a tiny bit of boilerplate. And you can do the sorts of things you expect to do. You get some tab completion, system.out.println. So I can print, what did I call it? I called it my name. And I don't have to put my semicolon on there and it will work. I have some features like I can say, I can list all my vars. I've only got one there. I can do things like I can create scripts, save them off to files. I can load and run scripts, that kind of thing. Or I can use it just to play with stuff. So I used this to play with some new features. I'll show you the new features later, actually. But I was playing with the convenience methods for collections, convenience factory methods for collections, to see what types of classes were created when I use those things. So JShell is quite a good way to play with the application, with the new versions of Java without having to play with it inside your application code. That is JShell. var, I just gave you a quick demo of var. Let's have a look at var, obviously inside IntelliJ IDEA, because otherwise I wouldn't be doing my job properly. So var seems like a very simple feature. It is. It's syntactic sugar to allow us to get rid of some boilerplate, if you like, around type declarations. So I can use IntelliJ IDEA. I'm compiling this in Java 15 actually, but like I said, this is available in 11. I can replace my explicit type with var, and then I can just declare it with var. There are some caveats. You could do that across the whole code base if you wanted to, but there are some places like if you do it here, and replace it with var, then you kind of lose all of the type information because you've got a rubbish method name here, which doesn't tell you anything about types, a rubbish variable name here, which doesn't tell you anything about types. And then if you get rid of the type information here, it might be argued that it's not super readable. If you're using it inside an IDE, the IDE can help you out. So we have a feature called inlay hints. Let me have a look. Inlay hints. Oh yeah, here we go. Inlay hints for Java, implicit types, and I can turn that on and off. So if I want to turn that on, it will show me the type information. That's kind of useful in this case where the type information was sort of missing, but it does kind of negate the value of having removed the type information in the first place, because you end up with effectively IDE replaced boilerplate. So that's kind of interesting. I could take that off, take those hints off. And then I don't get that. And IntelliJ IDEA will do the right thing when you start applying var across the board. It'll move the type to the right place. I don't want to go into that in too much detail because we've got loads of things to cover, and var is just one specific feature. But it's useful. It helps reduce boilerplate, but it is something that you do need to be a little bit aware of, because reducing boilerplate can actually reduce the readability in some cases. Convenience factory methods for collections. This is one of my favorite features in Java 11. Let's take a look at this. It should be under, collections. Yeah, collections factory methods. In Java 8, you would normally, if you have a set of values like this, not a set, a list technically, you might declare it with arrays.as list. In fact, that's usually incorrect because this list is not, it's not immutable, it's not fully modifiable. You can't add anything to it, but you can edit it. So probably what you wanted to do is you wanted to, where is it? It was in here somewhere. Oh my goodness, that's weird. I did have it somewhere. Wrap with an unmodifiable list. So what you usually want is you actually want it as an unmodifiable list. But then we end up with quite a lot of boilerplate there just to create a list of items. And if we've used other languages like Kotlin or Groovy, this is a little bit unwieldy. In Java 11, we can just replace this with list of. So we can have list of instead of this whole unwieldy, unmodifiable list arrays.as list. That's useful for list. It's really helpful for set, because in order to do set, you have to have a list and then a hash set and then an unmodifiable set. So you can actually just replace that straight up with set of, which is really helpful. You can do something similar with maps. Maps are a little bit ugly in Java because they're, in order to initialize a map to begin with, you might have to put it inside a static block like this, or have a big block of code to add. And again, if you really want it to be unmodifiable, you have to wrap it inside unmodifiable, which many of us don't get around to doing. You can replace this with map.ofEntries in Java 11. And then this allows you, let me do a static import for this, add a static import. And so then you can do a map of entries here in a more DSL type way. I think this is quite nice. This is, it's a more programmatic way to do it than have it in that horrible static block. The other thing to note is that if you have fewer than 10, then you can use map.of instead of entries, and then you do key value, key value, key value. Let me hide the parameter hints for that. Do not show hints for current method. And then we've just reduced loads of lines of code just down to a single line of code here. So that's really nice. Let's get rid of that there. Okay, what's next? Sorry, I'm trying to cycle through all my windows here and it's not working. Right, so that is convenience factory methods for collections, one of my favorite features. In Java 11, you can also collect to unmodifiable lists. In Java 8, we're doing a lot of collecting to list. So again, this is all kind of related to the idea of using unmodifiable, immutable data structures, which are better. They can be better performance. The JVM can reason about them better because they're not being modified. So you know that is the set of data. It's never going to change, and it's easier to make sure that we are secure and that other people aren't like modifying the collections unexpectedly underneath us. So this is something that we can do in Java 11. Next up is predicate.not. This is a kind of small addition to the language. It's kind of adding boilerplate, if you like, but it's a nice thing all the same. Let me look. It's in Java 11. In Java 8, if we want to check for something that is the negative case, we can obviously use our lovely exclamation mark, which is a tiny amount of text, but it means that we can't use method references in this case because it doesn't work with a method reference. If our preference is for method references, then we can use predicate.not, and let's static import that and put a not around our method reference. It's really a matter of preference. It's sometimes a little bit easier to read this because the human brain can kind of skip over the exclamation mark if we're not paying attention. So maybe we prefer to use not, maybe we prefer to use it because it allows us to use method references. It's a small thing, but it can make, the whole point about a lot of these changes is to move towards increasing readability of our code. Okay, next. New methods on the Stream API. I'm not going to go into this in a lot of detail because these are kind of useful cases that we're missing in Java 8. In Java 11, we can use TakeWhile. And so TakeWhile allows us to keep moving through the stream until some condition is met. And this was sort of missing in Java 8. I actually felt the pain of this when I was putting together a Java 8 demo, because what I wanted to do was iterate over an infinite stream, and then at some point like quit that stream when some criteria had been met. And it was not possible to do that. Well, I had a very interesting hack to get that to work in Java 8. In Java 11, you can just use TakeWhile. So just keep parsing the stream until some criteria is met. Similarly, there's a drop while, so you can ignore the stream until some criteria is met, or you can use them in combination with each other. So it just allows us to do more interesting stream processing, particularly with infinite or very large streams. Oh, did I just go upwards? Did I say predicate not twice? That's fascinating. New methods on optional. Optional came in Java 8. I really liked optional. I like the idea of being explicit about what is null and what is not null. But I was a little bit disappointed with optional in Java 8 because it, oh, that's not the right one. It's, right. Pay attention, Tris, use the right keyboard shortcuts. If you are interested in the keyboard shortcuts, they do pop down at the bottom there. New methods on optional. Because in Java 8, we had if present, which is a nice functional way of doing stuff. You can kind of wrap it inside a Lambda and do a particular thing. But that was kind of the limit of it. Everything else, if you had any weird edge cases or even not that weird edge cases around the optional not having a value, you ended up using if and else, or having some sort of conditional around it, which kind of took away a lot of the value of optional in my mind. In Java 11, optional is much more sort of functional style. For example, in Java 11, you can do an if, present, or else. So you can pass in two different Lambda expressions. So if present, obviously do this thing. If it's not there, then do something else. So you don't have to have an if and then an else. What else? In Java 11, we had introduced the idea of you can replace it with is empty, which is the opposite of is present. And that's a small thing. Again, it's like the predicate .not. It's a small thing, but it allows the human brain to reason about things a little bit better. For example, if I have not is present, my brain has to go, okay, it has to first spot my exclamation mark, and then it has to go, right, so if it's not here, this is the thing I need to do. And human brains are not very good at not. They're not very good at negation. They see the positive case and not the negation. So in Java 11, you can replace it with is empty. This is just a bit more readable. If the optional is empty, then do this. So our brains don't get tripped up over, okay, I don't have one of these or whatever. So that's kind of helpful. And there are some other methods like you can use or else throw. You can use or, which returns another optional instead of returning a value. And then you can use stream for using optionals inside stream methods. So this is kind of helpful. It just kind of brings the optional, it just makes it a little bit more functional, a bit less boilerplate, a bit easier to work with. There's a built-in HTTP client in Java 11. I haven't used it yet, but I do know it's kind of useful, particularly for testing and things like that. But it means we don't have to be dependent on external libraries for doing what a lot of us are doing in terms of like HTTP calls and microservices or whatever, things like that. Multi-release jar files. I wrote about this a while back, 2017. This is more applicable just for library developers, but library developers can now release a single jar file regardless of whether their users are using Java Java 8 or earlier, or 9 or 10 or 11 or 12. And that allows library developers to, if the users are using, say, Java 15, the library can use the features of Java 15 without the users being aware of that. So this is just really helpful. So you don't need to download like a Java 15 version of Spring or a Java 11 version of Spring. You will just have a single jar file for Spring. Jigsaw was the big feature in Java 11, Java modularity. I would say the majority of Java developers don't really care specifically about Jigsaw itself. Sorry, we're supposed to call it the Java module system. Um, but the Java module system has led to a bunch of improvements which are helpful for us as Java developers. For example, it allows us to use something called JLink, which allows us to build a small deployable with just the bits of Java that we need, just the modules of the JDK that we need, and then we can put those into Docker images or just deploy a small version of our application with a small version of Java to the cloud, for example. So this can help us to keep our costs down, keep times down, and just basically reduce bloat. So from that point of view, the Java module system has been very helpful. So that's all the features in Java 11, not all the features in Java 11, there's loads of features in Java 11, but that's the sort of key features in Java 11. So let's take a quick look at the features in Java 15. I can't see if there's any questions going on right now. I think it's probably, given that I've got a lot of stuff to get through, it's best to sort of get through the whole content and then see if there's any questions that I can answer right at the end. So Java 15, which is the current release. In Java 15, we have switch expressions. This is quite a nice feature. Again, this is about reducing boilerplate, switch expressions, which I can't spell. Probably many of us are not using switch statements because they're ugly. They look really nasty. And usually a switch statement is a sign that we have not done polymorphism well. However, there are cases, particularly at the edges of the system, where we are going to have to take raw inputs of data, whether from a user or a database or an external system, and put it through a switch statement in order to figure out what to do next. And in Java 15, we can replace these with a switch expression, which is significantly less code, and I would say more readable as well, because we can see straight away, if it's 20, then this is the port type that I want. We can see multiple cases together in one line, which goes here. We still have a default a sort of drop through if everything else is unknown. On top of that, a switch expression returns a value. So I can inline this, and so I don't need a temporary variable to store the result of that switch statement in. Again, this kind of helps reduce actual variables. Everything is just kind of can be immutable in this case. What is this suggesting? Duplicated code fragment. Okay, of course, because I have that twice. IntelliJ IDEA can obviously do the translation to the switch expression. You can also do things like, let's see if this is going to work. If I do Alt and Enter, I can create branches for my missing cases. All my cases are down here. So I can say, right, this is going to be, I don't know, thing. And this is thing as well. And then I can actually merge those two cases together. So, and then I don't need this anymore, right? Yes, I don't need that. So switch expressions are really nice, and in order for us to get familiar with the new functionality and make sure we're doing things correctly, IntelliJ IDEA will actually help us to write the switch expression, which is what we're expecting to see. My colleague Malagupta wrote some really great information about switch expressions. It's much more detailed. That is available from this link here. At the end of this presentation, I will provide a single link which will link to a page which has all of this information in. So you don't need to necessarily screen grab all of this as you go along, but of course you can if you want to. Text blocks is a new feature in Java 15. Text blocks. It's not uncommon in Java to find ourselves embedding other languages inside our code, inside a big string. And this will quite often end up with, so for example, JSON is a really good example, with loads of escapes in here and line breaks, and it might be that the formatting is relevant. We need to have all the white space in there. This has always been a little bit ugly inside Java, but what we can do in Java 15 is we can replace this with a text block. And then we just start it with 3 double quotes, we finish it with 3 double quotes, and we don't need to escape anything inside here. We just write whatever text it is that we want to be inside that text block. Also, the white space is from the starting point is significant, and you can see that in IntelliJ IDEA. It kind of shows you this is the starting point for the white space for this text block. So we can do that for all of our code here. HTML. That looks a bit better. The SQL actually doesn't seem to make much of a difference, but it's kind of helpful. The JavaScript is much more readable. The other thing that we can do with IntelliJ IDEA is we can inject a language. So here, let's inject JavaScript, and then we can actually, we can edit this as if it were actual JavaScript. So I get code completion inside here for JavaScript. And this is much more helpful inside text blocks because we don't have to escape all of our code because it's inside JavaScript inside Java. So text blocks is one of my favorite features in Java 15. Just makes my code much more readable. Oops, I pressed up. Again, Mala has written about text blocks. She did a really good job showing a bunch of examples for text blocks. Hidden classes, right, hidden classes is something I looked at yesterday and went, oh, I don't really know anything about those. This came in Java 15. This is really for library developers as well. This allows library developers to create and use classes inside their library that no one else can get access to, either through reflection or through using the wrong things. It's not really applicable to a lot of normal developers. What it does do, which is a good thing for us, is in the past, when a library developer gives you their code, their jar file or whatever, you can obviously see all of the classes, all of the structure, and it's possible to incorrectly use that code because you have access to it. With the library developers being able to hide stuff away and also encapsulation with modularity and a bunch of other features which have come in, that makes it much easier for us to see what the real API is, what we are allowed to use and what we shouldn't be using because it might change under the covers. So that's JEP 371 if you want more information about that. So those were the standard features that you can use happily in production in Java 15 should you happen to use Java 15. What you might want to use is preview features. I really like preview features. Preview features are, they're a way, now that we have these releases every 6 months, the language developers can give us features that are feature complete, they work, they are correct, but they allow us, the users, to play with them and go, oh, okay, but this keyword doesn't really work for me because it clashes with some keywords in my code base, for example, or this feature doesn't work amazingly for my code because I have these weird edge cases which it doesn't work for. So preview features, we can turn on preview features in Maven, Gradle, and IntelliJ IDEA, whichever system you're using to build your code, and then you can start using these new features. And don't use them in production because they probably will change from release to release. So you can use them, try them out, and then feedback if there are any problems to Oracle and the other OpenJDK developers. So we have some really interesting preview features in Java 15. Pattern matching for instance of. This is going to be a standard feature in Java 16. There are going to be some very small changes to it, but this is sort of fairly safe to use in 15. I shouldn't say that. Don't use it in production. Pattern matching, I keep using the Windows keyboard shortcuts here. Pattern matching for instance of. This looks like a small feature. This feature is going to open the door a little crack for a large number of pattern matching type features, which are going to come into Java, hopefully over time. In Java right now, this is not an uncommon pattern. You can say, this is a person, I'm going to do an instance of check, and then I have to do a cast to cast it to an employee to do employee-based work. I can replace this with pattern matching for instance of, and then this is what it looks like. I can say instance of, but then assign it to a variable employee, and then I use employee as an employee. It's great, it just reduces that cast. The cast is always a little bit of a smell, and we can apply this change across the whole code base automatically, and it will just do what we expect it to do. Like I say, in and of itself, it's not mind-blowing necessarily because you probably don't have a lot of examples of this anyway, but it does open the door to pattern matching type features which are going to come in later versions of Java. Mala wrote about this in her JDK 14 post, which she did a very thorough job of that, and shows how some cases it can really help reduce the amount of boilerplate that you have in your code. Records are my favorite feature. Records will also be a standard feature in JDK 16, so it's nearly ready to come. Let me look at records. Let me create a new Java class. I'm going to have let's call it, what have I got? I'm going to call it a customer. I'm going to create it as a record. This is currently flagged in IntelliJ as a preview feature to sort of suggest perhaps you shouldn't be using it in production until it stops being a preview feature. And then in my record, I can say I have an int ID and a string name. And that is it. That is my data class for a customer. I don't have to have a constructor, hash code equals toString getters or setters. I just have to declare that. If I want to, I can declare I can create a standard constructor, but I don't need it. So IntelliJ will actually tell me, you don't need one of those because you've already said that you've done that. But you might want one of these. Let me show you a record. You might want one of these if you are, let's create a canonical constructor, and then I'm going to say validate my fields. So that's what I might want my constructors for, so I can actually do that. But I might also want, can I convert this to a compact constructor? Not on this one. Records support compact constructors. Generate constructor, compact constructor. I don't need to give the record, I can't remember what they're called now, the record elements. I don't need to put those in there because it's assumed that they are there. Do I have a helper method? No. So I might do something like, I don't know, do some sort of validation in here which doesn't require them. So that's kind of cool. Another interesting thing about records is that records have getters, they have accessor methods, but those accessor methods are not called get ID or get name. They're just ID or name, because there's no need to have the get there. It's not necessary. One of the other things that you can do is, I think, let me get rid of this. Let's see if this works. It may or may not work. I can play with records and small data classes, and I can actually convert that back to a full-blown normal class if I want to, if I don't want to be using preview features. So that's kind of a helpful feature. I can also, will it let me turn it back into a record, convert back to a record? But then I don't need those overriding methods. That's fine. So I can convert to and from records, which is quite fun. Right, records, that has also been covered in this JDK 14 post. Sealed types. Sealed types are where if you want to take control of your hierarchy. So for example, I can say this is a sealed class and it permits child class to extend the sealed class. This is helpful again for library developers who want to control their hierarchy, or it just allows you to do good object-oriented design if you want to be really strict about what's allowed to do what. So let's say I have a new class. This is called another child class, and let's say I want to extend sealed class. I can't do that because it's not allowed in the sealed hierarchy. What I need to do is I need to add that to the permits list up here. And then if I do that, I also need to declare this either as sealed, non-sealed, or final, which obviously I can get IntelliJ to do for me. I'm just going to make that final. So sealed classes, I think they're a really interesting feature as well. These are preview features. There will be a second preview of this in JDK 16 as well in March. So this is not really production ready yet. It works, but it's worth trying out and seeing if it works for you and feeding back any information that you might have about what does or does not work. Sealed types. So if you want to know all the information, all the features that went into JDK 15, then look at Openjdknet. That has the list of all the features that are in JDK 15. What's next? The future. So I have alluded a little bit to the future because I've talked a little bit about what's coming in JDK 16. Here am I talking about 15 and 16, and most people are still on 8, and I'm going way ahead to 16, which isn't even out yet. But pattern matching for instance of and records will both be standardized in 16, so they're pretty much ready to go right now. Sealed classes, as I said, will have a second preview in 16, and there's a whole bunch of other features in 16. So 16 has some features for Project Panama. Project Panama is about, here's where I haven't looked into it in a lot of detail. It's about being able to talk to native code better. I don't know, Panama, bridging stuff, I guess. What's the opposite of bridging? So there's some stuff for Project Panama there. There are some features for these these features, for example, new previews. There's some more garbage collection stuff and a bunch of other stuff. So 16 looks kind of interesting. And going forward into the future, we can see with these 6 monthly releases, we're getting a lot of useful features that we as developers can use syntax-wise, but there's also a lot of work going on incrementally for wider ranging stuff. So Project Amber is a lot of what you've already seen. Project Amber is about reducing the boilerplate, increasing readability, making it a friendly modern language to work with. Valhalla is, amongst other things, about value types, which reminds me there is a change for Valhalla, which is coming in 16 as well. Loom is about lightweight threads on the JVM. That is that you can play with Loom now with a preview build of 16. I don't know if that's going to come in 16, but it's definitely it's in progress, and it's ready for people to play with if they want to see what this looks like. Project Panama I kind of mentioned about talking to native code more easily. There's been loads of garbage collection improvements, and there will continue to be garbage collection improvements, and a proposed new project around improving the startup time of Java as well. So there's a lot of big things going on in Java. It's not just about small syntax changes, reducing boilerplate, increasing syntactic sugar. There's like big structural changes going on underneath the covers, which obviously has to be very carefully managed because backwards compatibility is super important to the Java ecosystem. Right, so I've talked about the stuff that we as developers really care about more than anything else, but it's going to be a little bit difficult to sell the business on using a new version of Java when we're saying, well, actually we want to play with records, and they're like, well, we don't really care about that. So what is it that the business might care about that might help to sell them on moving to a later version of Java? I think the number one thing is probably performance. So there have been performance improvements in all these versions of Java. The more modern version of Java you get, the better performance that you get. So performance has improved in terms of use of memory. There's things like compact strings, which went into Java 9, I think, and using new the ability to use other CPU operations directly. So all of these things will improve the performance of Java. There's been a lot of garbage collection changes since Java 8. So Java 11 has some experimental garbage collectors you can play with. It moved to using G1 as the default garbage collector, which has proven to have a better performance for a bunch of standard applications, parallel full GC for G1. So there's been a bunch of garbage collection updates which you may find improve the performance of your application without you even really doing anything. Java 15 has production-ready ZGC and Shenandoah, and more improvements to G1. So even if you're moving to Java 15, the garbage collection improvements alone might help improve the performance of your application, but it's not always all about garbage collection. I think garbage collection gets blamed for a lot of poor performance, and it's quite often not the case. There are other improvements around the JVM specifically, which will probably improve the performance of your app without you having to do anything. In the link I'll show at the end, I have a link to a couple of documents which show some benchmarks of those things, so you can see what I'm talking about there. Cost. So if you are using things like JLink to produce small deployables, you could be reducing your cloud cost. If your performance is improved and you're using fewer CPU operations, if you're using less memory, all of that stuff can actually have can reduce your financial cost for running your application. The business does care about things like that. The other cost, which is interesting, is that if your application, your team are using modern versions of Java, this is very appealing to other Java developers. So it can reduce your cost in terms of staff turnover, in terms of attracting and retaining Java developers. So moving to a modern version of Java can also help you in terms of like the cost of your developers, if you like. I don't have a lot of time for tips for migration. I want to give a really, really high level overview. I think there's a lot of fear around moving off Java 8. I don't think there should be fear around moving off Java 8. I think that the ecosystem has become very stable, has proved that in the majority of cases, that moving off Java 8 to Java 11 is really not as tricky as we feared it might be. So I just want to give some pointers, and then I have a link to a more in-depth article at the end, which I've written about how to migrate from Java 8 to 11. Firstly, just run the application on an updated JDK. It might just work. The Java is designed for backwards compatibility. So the theory is that standard type applications should work on newer versions of the JDK, even if they're not making use of the new features of the JDK. If you have compiler warnings in your code, do address them right now. So things like there are compiler warnings put into Java 8 to point to things which are going to change or go away in the future. Deprecation warnings. Deprecation is being taken very seriously. Up until Java 8, things could have been deprecated since Java 1 and never removed. And that's not the case anymore. Things that were deprecated, there's a flag now where you can say deprecated marked for removal. And in a couple of versions time, that thing will go away. So if you do have any deprecation warnings, do address those. There are usually migration paths for each of those deprecation warnings. So it should be fairly easy to replace it with whatever it says it should be replaced with. Update your dependencies. This is really important. You should be updating your dependencies anyway. It's a security concern. The most recent versions of your libraries and frameworks will have addressed any security problems. So you will need to update your dependencies. The most recent versions of all the libraries will have taken into account the changes which have gone in specifically 9, but also 11. 11 also, as I said, it removed some code. So you may need to add some external dependencies. So if you are dependent on JAX-B, for example, you need to add that as an external dependency now. You do need to update your build tool. By now, we are 3 years on from Java 9, so I fully expect that you're all using the right version of Maven or Gradle, that everything will work anyway. But if you are going to move to Java 11, you must be using a version of Maven or Gradle which will work for Java 11, because there were a lot of changes 3 years ago in Java 9, so you need to make sure that the build tool does all the right things for the new versions of Java. And then when you have done all of those things, then you can compile against your updated JDK. And then once you start compiling against the updated JDK, then you can start using the shiny new features. If you want more detailed information about what are the possible gotchas for migration, some of the steps you can take to migrate your code, I did write about this in an InfoQ. So you can have a look at this article, and that will kind of help guide your migration path potentially. I am surprisingly more or less on time. Don't think this has ever happened. In summary, modern Java can help you, the developer, to write code which is, well, more fun to write, so that's great, but also is more readable. It reduces boilerplate. It allows you to do things like in the future write record classes which are just like 2 lines of code instead of 150 lines of getters and setters. It reduces boilerplate, it aids readability, and it also provides the business with better performance, lower cost, and a lower maintenance cost, because the code should be more readable and easier for us to go in and say, oh, I can fix this defect because I understand what this code looks like. There are 2 main upgrade options if you're on Java 8. One is to go to JDK 11, which is the current long-term support release, and probably get support from one of the vendors. The other is to upgrade to Java 15 and upgrade every 6 months. I think for a lot of enterprises, they're probably going to be interested more in the longer term support type thing. They want to sort of commit to a version for the next 3 years or so. So for enterprises, I'm guessing that going to Java 11 is more appealing to them. I also think potentially if you are on Java 8, you probably want to go to 11 first, and then maybe see if you want to go to 15 or not, see how it goes. But 15 has a lot of the exciting new features in, so I think that 15 is kind of really where we want to be going. I do think it's going to be important to upgrade now to reduce future pain. So when I'm talking about future pain, I feel like it's going to be a big step to go from 8 to 17. So 17 comes out next September. 17 should probably be the next long-term support release, but there's going to be a big difference between what you had in 8 and what you had in 17. It feels like doing a one step and then incrementally migrating every 6 months, at least in continuous integration. It feels like that will help to reduce the pain of any future upgrades. Great, so I have made it to the end of my talk. Like I said, this is the link, the Love Beyond Java 8. This is the link to the page which has got all the information, all of the links to more information, the slides for this talk, etc. That's all there. Now, if you want to win one of 5 copies of 97 Things Every Java Programmer Should Know, then click on this link here and leave me your email address. I need your email address because otherwise I can't contact you. But leave me your email address. I will randomly draw 5 from that. And then I will, if you are lucky enough to win, I will get in touch with you and find out if you want, if you want the book and how to get it to you. So that is all of my talk. Thank you very much for watching.
Thank you so much. And I would like everyone to give a warm round of applause. And I believe if everyone would be in the room, we would give you that with the crowd. But now I can see that people in the chat excited, and your presentation sparked a lot of interest and some questions. One of them I'm going to ask you here, and then we will move to the Q&A room on special chat. So the question is, how does non-sealed on the child class work? Doesn't that break the contract of the parent class?
That is a really great question. And that's the first question I thought when I saw like non-sealed. I was like, okay, so doesn't that break the whole thing? I don't know the answer to that question, but I think that if you read Mala's article about sealed classes, I think that should answer the question. But I think that's absolutely the right question to be asking.